This is Team 19 and we will be presenting our Ultimate Pong game.
So this is the top module created to nest every module we need to drive the game. We have a clock divider module to drive our 7-segment. We have a Pong module to create our game screen. And then we have our menu screen to create the start screen. We have our BG to create the game over screen. We have our score to 7 segs to decode our scores. And then we have our increment one to change the mode. And finally, we have our always block in order to decode which mode we will be in.
So this is our clock divider module. This module was primarily used in our project for using the 7-segment display. The clock was initially a 100 megahertz clock, but for the 7-segment display we needed a 200 hertz clock, so the values could be seen a lot easier on the 7-segment display. So through these two always blocks, it is essentially taking the input clock and using a divider value to change the clock accordingly until the desired clock frequency is reached.
This is our game module, acts as a wrapper for our square and our paddle modules. In this case, we essentially just create the game. We have our decoy balls as well as our paddle, and then we create our strobe clock to drive the actual paddles, and we also have our display driver to create the correct timings. And then, so these are all our wrapper modules. And then finally, we create our edges of the square in this block by drawing them, and then in this point, we determine when we actually want to draw the pixels of each square or paddle.
So this module is used to set up the paddle. Here are some parameters that give the dimensions of the paddle and the starting position of the paddle, which is going to be at the center of the bottom edge of the screen. This module takes in as inputs the buttons that are used by the players to determine the motion of the paddle. And that is essentially done in these if statements. This bottom always block makes sure that the paddle dimensions are always moved accordingly when the user shifts it either to the left or right.
So this is our square module. It acts as basically the pong ball as well as the collision handler. So we output the animations as well, and we output the score and our end game flags. And so this part is really key. It detects when we are colliding, and it'll increment the score as well as change the direction and speed of the ball. And then this block essentially checks all those conditionals and see if we need to increase the speed or not, or increment the score or not. And these are the collision blocks to detect collisions against the walls of the screen, so we can determine which way it'll bounce as well. And in the final place, we just assign the score or the end game flag to the actual Pong game. So we have our VGA driver module. This essentially takes in clocks and outputs the correct timings for our VGA. We have local parameters here to define where the active parts of the screen are and where the physical pixels end in the screen. We also have these assign statements to create these correct signals for our VGA. And then finally, we have these counter blocks to tell where we are in the frame and therefore help assign the correct pixels to the correct places on the screen.
Hi, I'm Patricia, and I'm going to be going over some of the modules we implemented in our Ultimate Pong game. The first one being the Increment One button. So this basically either makes sure that your VGA screen is on our home screen or actually playing the game. So at first your button is 0, and then once it's clicked, it is incremented by 1. And once incremented by 1, that prompts the game to begin and you can actually start playing. The following module is the Sram module, and basically what this does is it uses outsource Python code to download these mem files into Verilog, and so it just loads full physical images into Verilog so that we could then use it on our home screens or backgrounds and other things like that. The next code that I want to talk about is the background generator module. And this is somewhat similar to the SRAM. However, rather than loading in entire physical images, what this does is it basically loads color palettes or bitmaps of images and then outputs them onto the VGA, as can be seen here by outputting all the colors onto the VGA. And this is how we got our background while you're playing the game. The last module that I wanted to discuss was the menu screen module, which again is pretty similar to the background module. And this is basically how we got our menu screen loaded. And it also essentially just creates color palettes for the images that we wanted displayed and then outputs them onto the VGA so that we can have our menu screen. Thank you.
This is our start square module. It'll take in a few parameters such as a clock and the initial starting positions, as well as the dimensions of the square, as well as the width of the screen, and then we'll output the correct VGA pixels for its animation. And then this block is probably one of the key blocks. It's used to determine which place the square will start and the directions of the square, and finally we'll check which edge of the screen has touched and move in the appropriate direction.
This is the module that drives the score to the 7-segment display so that it is visible for the players to see while they're playing the game. So this module takes in the 200 Hz clock outputted by our clock divider module, as well as a current score. So what it does is it calls our Bcd Converter module to convert the binary bits of the score to its Bcd equivalent. And then it also calls our num hex module, which essentially outputs the hex value segments that are needed to drive the score to the 7-segment display. And it does so doing this always block. So this is our binary to BCD converter. We used a double dabble algorithm to achieve this transition. So it is pretty much taking and shifting the binary digits to the left once, and then adding the front removed binary bit into the end of the BCD bits. Once the shift occurs, the BCD bits are checked, and if any BCD digits are greater than 4, 3 is added to it. And this process will continue until all of the binary bits have been analyzed and removed. So this value is the one that takes in the BCD encoded values and then finds its corresponding segments in hex. So these segments correlate to which segments need to light up on the 7-segment display in order to show the appropriate value. So this part of the demonstration is going to show the different screens that we used for our game. So this is the main menu, or the main screen of the game. So this is our game screen where the actual playing of the game is done. So right here is where you can navigate the paddle according to the movements that you want the paddle to do. And this is where the ball will bounce around and all that stuff. So once the game is over, the game over screen will flash, and then you'll be directed back to the main menu, and you can begin the game again.
So let's just start a new game. As you can see, the ball starts out very slow, and as we hit it, it'll get faster. So it'll basically travel in the direction that the Pong paddle is going. However, if you don't move it, it'll just travel up faster and the opposite direction. And it'll get faster and faster, and every 10 hits, a new thing will happen, which is new balls will spawn. You'll see that in a bit, if I can get through this. Yeah, as you can see, that ball was just a decoy. It didn't trigger a game over. But we can keep doing this, and, well, we got a game end there, but essentially we can keep doing that, and it'll spawn more balls up to level 60 for a total of 6 decoys. And those speeds will increase, and the goal is basically just to distract you. They won't trigger a game over event. That would be too difficult, I think. But yeah, we can keep playing. It'll speed up. It's hard to play while filming, but I'll try. As you can see, we can hit both of them, but one of them's clear, the real one. Or maybe not so clear, but that's the purpose of the game, and we get a game over, of course. And yeah, that was a game over screen. I'll show you. It flashes real quick, but I can press the left or right button and it'll restart.
So this part of our demo is showing the score, and so the score will increment each time that the ball touches the paddle.
So this is just another little clip of the game running. As you can see, as the ball hits, it starts to speed up and then decoy balls get added. That's already seen in the previous demo clips, but for now I just wanted to talk about a few improvements we could have added. For one, we never got the highest score module working, so the FPGA board doesn't actually display the highest score on the 7 segment. Another thing we could have added was possibly better graphics to make it seem more realistic to an actual arcade game. For example, as you can see, our ball is a square, not an actual circle. And lastly, another thing that could have been added to just make it more fun and entertaining for the player would be some music. Maybe the music could get faster as the ball also gets faster. However, we had some time constraints and also some of the things we were testing weren't working, so we ultimately had to decide to cut them out. However, I still think that it turned out fairly nice and really fun, and it's kind of realistic to what the actual game would have been like. The ball goes faster, it moves in different directions when it touches the paddle, and I think that the decoy balls was a nice touch.